be talking about graphing quadratic functions in standard form. Y equals ax squared plus bx plus c. Now a is the same thing as before. What a tells us is that whether the graph is going to open upward or downward. If a is positive, then the graph will open upward. If a is negative, then the graph will open downward. But we will see that once we graph it on the calculator as well. Now, axis of symmetry, just like we talked before, is the vertical line that cuts your graph in half. Everything around it will be symmetrical. How do we find that algebraically? We solve for x equals negative b over 2a, where negative b, where the b is the coefficient of x, and a is the coefficient of x to the power 2. We will solve this in details later on. Now the y-intercept is wherever the graph touches the y-axis. Now in standard form we can tell right from the constant in your equation. So in this case c is your y-intercept. Now how do you find the vertex algebraically is something also we're going to discuss in details later on. Now let's move on to our first example. Y equals negative x to the power 2 minus 2x plus 8. Now as you can see, the a is the number in front of the x to the power 2. So a in this case is a negative 1. B is the coefficient of x, so b in this case is negative 2. C is the constant that's by itself, and in this case it's 8. Now, the one thing that we can directly know from the equation is your y-intercept. The y-intercept is the constant that's by itself. So in this case, my y-intercept is 0, 8. And you can mark it on the graph right away. That's your y-intercept. Now let's move on back to the equation. The axis of symmetry can be found by solving the equation x equals negative b over 2a. Now b is negative 2. So put that in parentheses and don't forget the negative in front of it. So it's negative whatever b is over 2a. And a in this case is negative 1. That's why it's very important to know what a, b, and c are before you start solving for the axis of symmetry and the vertex. So x in this case is negative times a negative 2, which is a 2, over 2 times negative 1, which is a negative 2 in this case. 2 divided by a negative 2 is a negative 1. So the axis of symmetry in this case is x equals negative 1. The axis of symmetry is going to be a vertical line that's going to cut my parabola in half. So you can draw that and represent it on your graph. Now, how do you find the vertex from the standard point or from the standard function or form? Is after you find the axis of symmetry, that's going to be the x of the vertex. So the x of the vertex is going to be negative 1. It's exactly the same as the axis of symmetry. Now to find the y of the vertex, what you need to do is you need to plug in negative 1 back into the equation. So let's go ahead and do that. I'm going to draw a line so my numbers won't just coincide. Okay. So y equals negative, and instead of the x, I'm going to put in negative 1 for x squared minus 2, negative 1 for x plus 8. Now remember, you can plug that into your calculator and you can find that what the y of the vertex is. So go ahead, take a minute and do that. So it's going to be negative 1 plus 2 plus 8. Now how did I do that? Negative 1 to the power 2 is going to be a 1. So negative 1. Negative 2 times a negative 1 is positive 2. And you can just copy the 8. So negative 1 plus 2 plus 8 is 9. So my vertex is going to be negative 1, 9. Let's plot that on the graph. So that's my vertex. Now let's go back to my function. Now I can double check if all my answers are correct by putting this equation y equals. And remember, if it's a multiple choice question, you can do that right away. So negative x to the power 2 minus 2x plus 8. Now let's graph it. Let me make this smaller so we can see the graph. Now I can see it's an upside down parabola, and I can tell that because the a is negative. So if a is negative, it's going to be upside down. Now, in order to find the x-intercept, as I can see, they are pretty points. I can tell that the x-intercept is a 2 in this case, and 1, 2, 3, 4, and negative 4. So we have two x-intercepts. I can also tell that my y-intercept is also a pretty point, so I can count and can find that my y-intercept is 8. So I can know either from the equation or from the graph once I graph it. This is how I can tell my y-intercept. I can also go into the table and find out what all the numbers are. Now remember, the vertex is the point where everything around it just repeats. So I'm going to go up a little bit. I'm going to find that point where everything surrounding it would just be symmetrical. So look at negative 1, 9. I have an 8, 5, 0, negative 7. I have 8, 5, 0, negative 7. So as I can see, my vertex is negative 1, 9. There you go, negative 1, 9. So you can either find it algebraically or you can go to the table and find that out. Now remember, if I ask you to show your work, you have to do it algebraically. If I don't ask you to show your work, you can always go back to the table or the graph to check what the vertex is. Now I can tell that the x-intercepts are 2, 0. It's the point having a y of 0, and negative 4, 0. Now let's take some pretty points and let's plot these points. So I'm going to take everything that fits on my graph, all of these points. So go ahead and join me in plotting these points. So always take as many points as you can, all the points that can fit on your graph. So you would have a good looking parabola. Once you plot the points, connect them. And as you can see, your parabola looks exactly the same as the one on your calculator. It even looks better. See that? It looks exactly the same. Now don't forget to always label or make sure that you have all the important points, which are the vertex, the y-intercept, and the x-intercepts, and a couple of other points that fit on your graph. Let's go ahead and answer the other questions now. What is the domain of such a function? The domain of parabola is always from negative infinity to infinity, because it's always going to be extending on the left and on the right forever. The range is going to be from bottom to top. So as you can see, my graph is going all the way down and it's never going to stop. So that's a negative infinity. Top is going to be the highest point, and in this case, it's the y of the vertex. So the y of the vertex in this case is the 9 with a bracket, since the parabola is actually going through the vertex. Now that's it for example number 1. Now let's move on to example number 2. Now what we're going to do is we're going to be doing this on the calculator and then doing it algebraically. Now remember, if I need you to show me the work, you have to do the vertex algebraically. Now let's go ahead and graph it. Okay, so x to the power 2 plus 8x plus 6. And now, before I graph it, I want to remind you that the y-intercept is always the constant that's by itself. So the y-intercept is 0, 6. Okay? Now, Let's go ahead and look at the graph. Now, so far, in all of the examples that we've been doing, the y-intercept, the x-intercept, and the vertex have been pretty points. So I was lucky. Now, what do we do if they are not pretty points? That's something that we're going to be learning how to do later. But now I can know that my x-intercepts are -1 and -3. I can tell that my y-intercept is 0, 6, which I know that from before, and the vertex looks to be -2 and -2. Now let's double check all of that from the table. Now remember, the vertex is going to be that point where everything around it is symmetrical. So let's double check. I have 0, 6, 16, 30, 0, 6, 16, 30. So my vertex is -2, -2. So let's write that down. And the x of symmetry is always going to be the x of the vertex. So if the vertex has coordinates -2, -2, the x of symmetry will be x equals -2. It's going to be a vertical line going through the vertex, cutting the parabola in half. Now, the x-intercept we discussed is going to be the points having a y of 0. So in this case, -1 and -3 are my two x-intercepts. Now let's go ahead and try to find the vertex and the axis of symmetry algebraically. So like we discussed before, to find the x of the vertex or the axis of symmetry, I use the rule x equals -b over 2a. So it would be wise if you discuss what the a, b, and c are even before you start solving for x. Now a is the number or the coefficient of x to the power 2. In this case, it's 2. Remember, it's positive, so your graph is going to be opening upward. It's good to know these things even before you graph it. The b is the coefficient of x. In this case, b is 8. C is going to be the constant that's by itself, so c is 2. Now, if I apply the rule, it's going to be negative parentheses, b is 8, over 2 times a, and a is 2. Now we have -8 on the top, 2 times 2 on the bottom is a 4. -8 divided by 4 is a -2. There you go. X equals -2. It's going to be a vertical line, and that's your axis of symmetry. It's x equals -2. Now to continue to find the vertex, you use that x, which is -2, and you plug it back into the equation to find the y of the vertex. So the y of the vertex is going to be 2 times 2 to the power 2. See how I replace the x by a 2 or by a -2. So I have to put a -2 in there. Plus 8, open parentheses, -2 replaces x, plus 6. Now you can plug that into your calculator and you can solve it. Or you can just solve it algebraically. -2 to the power 2 is a 4. 8 times -2 is a -16 plus 6. So 2 times 4 is an 8 minus 16 plus 6. Now if you add those, that's going to give you a -2. And that's what I found earlier, that the y of the vertex is a -2. Now let's plot the point. Now remember, this is going to be opening upward. Go back to your table and get all of the points that can fit on your parabola. Okay, these are all the points that can fit on my graph. I'm going to connect them, and that's going to be my parabola, opening upward, having the important points, which are the vertex, the x-intercepts, and the y-intercept. Now that's the lesson for today. I hope it was helpful. Now let's go ahead and find the domain and range. I almost forgot to do that. Now the domain is going to be always from -infinity to infinity. The range is going to be from bottom to top. In this case, it's going to be from the y of the vertex, which in this case is -2, all the way up to plus infinity since it's opening upward. Now that's everything for the lesson. Make sure that you watch the video again if you have to. If you need more practice, refer to the practice for this lesson.